of water for the Fargo-Moorhead area if needs be. But if I would argue in here that if it wasn't for political reasons in here, then I might, as a scientist, say, why not go to a much surer bet on water and look to the north and the east, and maybe like somewhere like Lake of the Woods as a possibility. But of course, that's politically impossible, probably, because it goes across, we're talking about a state line and something that would be very difficult in terms of achieving that type of a goal. So the bottom line in here then, when it comes to the Red River and to effects of climate in here, is that it seems like we're in a wet cycle. It seems like groundwater is high. It seems like full discharges are very high. We've got to keep working on solving the flood problems. Hopefully we'll get a diversion in the plans for that will help with that. But at the same time, we've got to prepare for that other extreme, which is drought, which could be equally difficult for Fargo and for Moorhead also into the future, particularly as we look to 2030 and times like that into the future. So, so a final thought in here. Kevin, do you want to deal with this bit? Okay. So the problem with carbon in the atmosphere now has grown to be, the additional carbon in the atmosphere has grown to be extremely large in here. And so these particular authors, there's a group of 4 authors there and headed up by a guy called Sokolow. This is an old study. There are bits of it that don't really work, but it's a nice set of ideas that are expressed in here. And basically they were saying then that they're saying in this study, and it sort of goes along with the ideas from IPCC, that if we keep on the current path of burning fossil fuels and adding to the carbon that's in the atmosphere, we're heading into unknown zones and here into the future. And 2030 could be getting close to those zones that we'll feel very uncomfortable in into the future. So they say, look, let's look, if you just sort of talk about the problem, and Kevin has talked about this, and the way that people think about the problem in here, sometimes it's just too big. There's just no way you can handle a problem this big in here. How would you go about even setting up ways in which you could convince people they need to act politically, they need to change their entire ways of lives? How can you do those types of things? It's almost too big. So what Sokolow and companies say, look, don't look on it all as one giant problem. Look at it as a problem that can be solved in pieces in here. And they talk about stabilization wedges is what they're talking about, okay? And so they say then, let's take the additional carbon that's going to be pumped into the atmosphere by the year 2050 by all these additional people that are on Earth. Let's take that amount of carbon and let's divide it up into 1 billion ton wedges of carbon. And let's just see about how we might go about reducing those. And so what they do then is they say, let's sort of divide it up into things which are pretty familiar to us, okay, as strategies for reducing carbon in the atmosphere. For instance, over on the left then, we talk about carbon sequestration, okay, carbon dioxide capture and storage in some way. We're working on that, but we're not there yet, okay, in terms of some of those things we might do. They talk about nuclear fission. Well, nuclear fission is a little bit difficult at the moment, but at some point in the future then, in here, whether or not it's by 2030 or not, we're going to have to move a lot more towards nuclear than we are probably at the present day. But if you look at all of these wedges that they define in here, most of them are beyond the capability of certainly individuals. Most of them are beyond the ability of cities in here. Some a bit more than others maybe. But there's one on here then that is within something that can be addressed by the city in here. And that's the one that's red on this particular graph. And that red one then is energy efficiency and conservation in here. And I think then that we are very proud to see the progress that the city of Fargo has made with respect to these issues then of the efficiencies and conservation in the last decade or so, maybe a bit longer. But we can hope then that as you plan for your future in here, that a much greener city, and you will do everything you can to make that greener city more realistic as we come into the future. So I think that's something that where we can participate as individuals and we can participate as a city then in working towards those particular goals. Finally, thank you.
Let's give another big round of applause to Dr. Allan Ashworth. That was an excellent presentation. And to also Dr. Kevin McCaul. My guess is we probably have a few questions from the audience. Would you guys be willing to answer a couple of questions? We don't want to hang around too long. I know it's nice outside, but in case we've got a question, anybody with a hand up that wants to maybe ask the first question?
I was wondering about that cycling of dry and drought and wet. Has anyone postulated a natural phenomenon? What that period is?
Yeah, so the question relates to the causes maybe of the natural wet and dry cycles. And one thing that we've learned, and hopefully John can come in on this answer in here some way. One thing we've learned is that the Pacific Ocean is actually a long way from here, but it's quite important in our climate on the Great Plains. And the El Nino, La Nina cycles that are talked about and reported even in the paper today, I guess, these are important, and they do have effects out here on the Great Plains and the weather that we would see out on the Great Plains. And so we know the Pacific Ocean is very important. Now, the cycle length of the 20 to 40 years is too long for El Nino, which is typically 5 to 7 years in sort of length. Numbers like that, it varies quite a bit. But there's another big oscillation out in the Pacific Ocean that's called the Pacific Decadal Oscillation. That's also due to pressure changes out in the northern Pacific Ocean. And that has effects. And so there are some climate scientists at any rate are trying to link the effects of Pacific Decadal type oscillations back into the types of cycling you're seeing. But it's not a one-on-one. It's a much more complicated system. John, do you want to? You can probably comment on this much better than I can.
Thank you, Alan. It's not my talk tonight, so I'll sit down. But the Pacific Decadal Oscillation, it turns out, is a phenomenon that involves a cooling of the waters around the rim of the Pacific versus the water temperatures in the interior of the Pacific Ocean. So it's a little different from El Nino, La Nina, which is more of an east-west gradient. This is more of a around the outside edges of the ocean as compared to the center. And it does have a span of about 20 or 30 years or so when it seems to shift back and forth. And it turns out that during the cold phases of the Pacific Decadal Oscillation, the La Ninas tend to be a bit stronger and more prevalent, and during the warm phases, the El Ninos tend to be stronger and more prevalent. And there is a very strong relationship between rainfall and El Nino, La Nina in the Rocky Mountains, in California, in the Pacific Northwest, and that trend does even go into western parts of the Dakotas. It begins to lose its relationship as you head out into the Great Plains, and so the relationship is not as continuous here as it is there, but clearly there are effects, and I feel pretty confident that cyclical nature that you see of rainfall in western North Dakota is likely directly related to Pacific Decadal Oscillation changes. There are other cycles around which we could get into. There's one in the Atlantic, there's one over the Arctic. All of these things have effects, and it's very difficult to weed out direct causes and effects in these different relationships in many parts of the world, especially here in the Fargo area where we're right in the middle of North America and in the middle of the Great Plains, and then we have so many different things that influence the weather.
Do we have any other questions or comments?
Global warming, does it parallel at all?
I am going to walk around to John Wheeler again because I'm a geologist and we have no record of tornadoes. But John can tell you a little bit about storminess and things like that, I'm sure.
Well, there have been a lot of studies that have tried to find that relationship, and some seem to find a relationship of an increasing amount of measured amount of storminess, and some have failed. And I was at a conference in San Antonio about 4 years ago, a weather meteorologist conference, American Meteorological Society conference, and I sat in on a climate change panel. No, it wasn't a panel; it was a symposium. And the interesting thing was, the first scientist who presented was Ken Trenberth, who was mentioned in the Forum article today, talking about increasing tornadoes. And he was speaking, the three speakers were speaking about hurricane intensity and its increase. Now, this was 2007, so this was 2 years after Katrina. And Ken Trenberth gave this speech where he dealt with general energy relationships and sort of volumetric water vapor, and it was very complex. It was clearly a perspective that comes from a climate modeler. And he tried to show that hurricanes had been increasing in intensity throughout the 20th century. And he was followed by a scientist by the name of Richard Lancy, who works for the National Hurricane Center, who they almost came to fisticuffs. And his point was quite different. And he showed that, in fact, that the 2005 year was not, in fact, probably even the greatest hurricane season on record, that there was one in 1933 which had something like two fewer hurricanes. But this was before satellite technology and all the way. And then there was a third scientist who came on, whose name escapes me, who kind of lambasted both of them for talking about this in the context of climate change and global warming, because he said they were looking at, minutiae details. They weren't looking at the processes correctly. And I'm already going too long on this answer. But I will say this. When you look at the news this spring of all the tornadoes, you have to understand that the tornado outbreaks are due to storm systems that have a tremendous amount of spin and a tremendous amount of instability and not too much capping or warm air in the upper atmosphere. And none of that really is probably related to global warming. And it's quite possible you can show a relationship between increased temperatures and future increased storminess, but it's very difficult to show any trend that has started now. Fair enough?
Allan, in your presentation, a lot of times you say that you haven't always believed in climate change. And what was it specifically, just like Dr. McCaul asked, what would it take for any of us to change our mind one way or another? What was it that changed your mind?
Yeah, I didn't mention it tonight. So what happened was, as the ideas started to come out, it would be mostly in the form of single events, like we had a single year that seemed to be warmer than another year. And the questions were, well, how are we measuring those numbers in there? And then, of course, the year after that, we would say, well, it's not as warm as it was last year. But over time, then, what happens is there's an accumulation of data over time. And data which has a lot of variation in it starts to show trends. And